three shapefiles. One is for the river, one is for identifying the boundary locations, then constructing the boundary which will make the watershed. Okay, so this is the main river. For this one, already the ridge lines are defined. So in the topo map itself, it is defined. So if you take this point of interest, for this the watershed is already there. So that will not give them a learning process. So what I did was I consider tributaries. So I will do one tributary with them and I will make them to do one more. Okay, so you can pick this one as first example and this one as the second example. So for that, you require three types of shapefiles. So in an universal format in GIS, you can make three types of shapefiles. One are point theme, like this dot. So point of interest. So you can make several dots, which can represent rainfall stations or location of a town or something like that. Or you can make polylines. So that may be a ridge line or a river line or a transportation road or something. Yes, stream, correct. So if you want to, the third type of theme is polygons, that is watersheds, counties, or states or something like that. So first we are going to make a polyline. So for creating that, here at the corner you see a catalog.
Yeah.
So that catalog you will have to open. Okay. So now you have this catalog, but browse to that folder what you are using. Folder connection, this one. Is it the OneDrive one? Okay, is it correct? Hydrology?
Yes.
Okay, so in this folder, we are going to create three new shape files. So just right click.
On the folder?
Yeah, so go to this folder. You get, say, keep it somewhere here in this window, right click.
Okay.
It gives you a create a layer option, right?
Yeah.
So click on that. And then here, no, this is not the right one. This is not the right one. It's in the catalog. Yeah. So go to home. Yeah.
Documents.
No, 1 second.
Yeah.
Yeah. Be in the folder and just stay in that link prompt, okay? And then right click. Yeah, and then right click. Go to new.
Okay.
And then go to new shapefile. Okay? And name that one as a stream 1. And then select polyline option. Okay?
Yeah.
And coordinate should be, go to edit. Okay, so we need to do one thing. Cancel this, cancel this. Go here and select point of interest, right click, properties, source. Okay. Okay. Go to
Layer properties.
layers and then properties. And then go to the coordinate system. And this is 1927 UTM 16th zone. Okay. Select that. Yeah, coordinate system. Yeah. Select this grade one.
This one?
Right click, yeah. Yeah, right click. Add to favorites.
Okay, the 16 north, right?
Yes. Add to favorites and then click OK.
Okay.
Now go to catalog. Stay there and right click, new, shapefile, stream 1, polyline, and then edit. Select that NAD 1927 UTM zone 16.7 in your favorites. Okay. Otherwise, you will have to go to geographic coordinate system and pick that one. But I didn't remember exactly what is that, so I went and used this option to
Yeah.
save it as a favorite and use it. Okay. So now, so when you make the shapefile, if you don't declare the projection system, it won't really lead you to anything. You will be able to complete all the work, but when your finished product is there, it will not have a projection system, so it will not make any sense to you because it won't align correctly. Okay, so you must complete this step. So likewise, stay there, right click, go to new shapefile. Here you say watershed boundary points. So let it be a point theme and declare the projection system as you did earlier as NAD 1927 and
So
click
this
OK.
is to again polyline feature type.
No, point.
Oh yeah, bounded points.
Yeah. So then go to the same, right click, new, shapefile, say, yeah, watershed boundary. Say this one as a polygon. Okay. Edit, NAD, click OK, click OK. So you have 3 of them newly created, but they are empty. One is watershed boundary points, another one is stream, another one is the boundary which you really aim for. Okay, the other 2 are going to assist you in understanding the concept. Okay, so now yeah, I think now we'll have to edit. So go to customize, go to toolbars and select editor toolbar and pull that one to the top.
This one.
Yeah, put it in the main ribbon. Okay, and go to editor and say start editing. But when you do the start editing, first we should have the stream, then only we can work around that. Okay, so go to stream, select stream, this one. Yeah. And then from here, construction tools, select line. Okay, so from here, so you see this is the focus one you are doing. So you can see here an inverted V.
Yeah.
See, this is the river. You start here, one single click, go and connect to this second click, and in between I'm tracing down. So I'm going further towards this V. So you have scopes to go here. So double click to end it. You can use the arrow to go up.
Okay.
Yeah. So now you have this main tributary, okay? But this main tributary also has other small tributaries joining. So from here, another one is coming and joining to this, okay? Double click to end it, okay? So likewise, you can see another one coming here. Okay. Likewise, you have so many of them.
Okay.
So you can pick few of them to give them a clear understanding of this whole river stream structure. Okay. So I have one here, another one going through this, to this, to this, to this, to this, to this, to this. Okay. Likewise, you have one here too. So I'm going very fast, but you are doing very well. Very proud of you. Okay. So likewise, you do this. So you have, we can have n number of, say, so many of them are there, right? So you can have as many as you want, but limited to, say, these basic things, so that they will have an understanding of the whole plot, which are going to be covered by them. Okay. So I don't see anything very prominent. So there is one here prominent, so that can come. Another one prominent, that can come, but you can add it. Okay. So to make it more visible, you can go and select a bigger option. Say, double click on that.
This?
That line.
Oh.
No, below that there is a line, right?
Oh yeah.
Yeah, double click on that. So select that highlight or something, say, which will give them a clarity, because they should. Some of them will ask you, "Oh, this is not appearing for me," all those stuff. So if you put this one, they will be clear. Okay.
Yeah.
So now it is still in the editor mode, so you will have to go to editor and stop editing and then save your edits. Okay. So now you created a shapefile, you declared the projection system, so this one is usable universally. So if you take the whole US map and take this one and put it over, it will exactly go to the place where it is. Make sense? Okay. So now this is the first step. So once you did this, now we will have to construct these points, watershed boundary points, so that the pathway to your boundary will be clear. Okay. Before that, please understand, this is a tributary of this main river.
Yeah.
So you can see here there is another tributary,
Oh.
right? It's going something like this. So your watershed will have a boundary. So inverted V's are the one used for tracking the stream. U's are the one which are the boundary edges. Okay. So now go to watershed boundary points. Then go to editor, start editing. Select watershed boundary points in your this one. Yes. and then select the points for your display. I mean construction tool. So start with this junction point, okay? Put a dot there and put one on this U. So whatever is the adjacent U, you put it here, okay?
You meant this?
U means this one. So inverted V for river, U for boundary.
Yeah, and this, and gonna be this, right? And
Yeah.
This.
Yes.
Okay.
So that's absolutely correct. So, but if you go here, this is for this tributary. So this tributary is already part of this system.
Yeah.
So you will have to select this one and then select this one for your next point. And the next point is going to be this one, because if you choose this U, it is going to be inclusive of this watershed. So you will have to travel on its edges.
But I can still select this, right? Because my tributary doesn't involve this U.
Oh, you are in a different tributary?
No, the same one, but I did not add this one. I did not
Okay.
give tribute for this.
Yeah. Don't do that. That's wrong.
Okay.
So that is why you must make them to draw this one
We
too.
have to cover every inverted.
Possible,
V.
yeah.
Okay.
Make sense?
Yeah.
Yeah. So, because this tributary contributing area also comes to this stream, so you cannot exclude that. Okay. So, travel close to the next one, which is this. Okay. And then you hit the ridge. So that black line is a ridge already given in your topo map. Okay, so now you will have to, so this gives you a help, so you can travel along that and make points for your watershed. Okay.
Yeah.
Go to this edge and start coming to the other side through this ridge. So when you come to this U boundary, so here you start with this U boundary because this watershed ridge is traveling slightly differently, but for our watershed, this U will be another contributor and this U will be another contributor and this U will be another contributor and it will end here.
Okay.
How much you understood?
So this stream, once we're done creating this thing, and we're not supposed to create any watershed boundary points in this stream.
Yes.
We should create something around the stream.
Yes. So conceptually, understand a watershed, how the concept works. Okay. So this is a watershed. Okay. So all the water falling in this territory will be coming to this river. Okay. Maybe this is a better picture with the tributaries. So the U, what I talked about is this point.
Mm-hmm.
The V, inverted V, what I talked about is this point. Okay. So this one is called berms and this one is the valley point. Okay. So this is the ridge, that black line what I used. Okay. So now I hope you can relate that. Okay. Now you go to this point also and select a more appealing color for students to visualize how this pathway is. So now this dots what you made, okay, okay,
Mm-hmm.
needs to be connected. So you may be asking me a question. So what this black line, which already the topo map provides? Suppose if that map is not there, how I will identify? So this is the elevated point. So from here, one river stream goes this way, another one goes this way.
Mm-hmm.
So this is the which we call a plateau line. Okay, so you can see the contour. Suppose if you take this line and want to set up your boundary for this one,
Yeah.
so you will take this U, you will take this U and go here, and then this is two different lines. I will take the midpoints and then try to come along with the other U points to finish it. Okay,
Yeah.
so this can have a sub watershed.
Okay.
Make sense?
Yeah.
Likewise, this one can have a sub watershed.
Okay.
Okay,
Yeah.
so
This black line is something which is given to make us clear that they are separating both the watersheds.
exactly. So this is done. So this is done by a field surveyor.
Okay.
So they conduct the survey, collect the data, document it as a topo map, and provide it to the end users. Okay, cool. Now let's take the editor, stop editing, save your edits. Okay, so this file is ready. Now you take the watershed boundary. We are going to edit that. Start editing, select this, choose the polygon. Okay, so start from this edge and traverse it in such a way that you cut it perpendicularly. So like the way, so the normal means, okay. So I will cut it perpendicularly like this. In a curvy, this one we will call this one as an orthogonal cut. Okay. So track down this to set up your watershed boundary. Yeah. Go ahead. Any questions?
For
Okay.
now.
Okay, good. I thought Daniel, he must have this recording, right? He did not provide you?
No,
Okay.
I didn't have recording.
Okay.
No, I understand the whole concept, but I didn't have the steps to navigate through,
Oh, okay.
like where to click for what in the software.
Oh, okay, okay, okay.
So that I missed.
Okay. Whenever you have any questions, please let me know. So we are traversing. Say in between the dots also you can have a connector which will make it more smoother. Okay. Double click to end it. So this is one trial they make, and ask them to do another one here. Make them 3 shape files: watershed 2, stream 2, points 2, so that they will be more clearer about this concept. Okay.
Yeah.
So after doing that, make sure to stop editing, save the edits. Okay, so whenever they make a watershed, there are 2 important things they try to extract out of that. One is what is watershed area, and what is the hydraulic length. hydraulic length is the longest flow path. Okay, so the longest flow path can be identified using this measure tool. So this measure tool, you can just take it and run through that, and say you have possibly couple of combinations of it, right? Say it can be either this one, so the total length is about this many meters, right?
Yeah.
Or you can clear that and try this length or try this length. So they will make 3 length measurements, but when they make the length measurements, let them stick to US, this one. Say here they have distance, you can put it in miles or feet. Let them not use kilometers or meters, because here all the technical literature talk about MKS system. Okay, so make them to change using this drop down icon. Ask them to select miles or feet and then use it. Okay, so that is going to be a small note they will have to create in a notebook. So trial 1 length, trial 2 length, trial 3 length, and pick the one which is the longest. Okay, and then the other one is to find the area. Okay, so now the editor is closed, right? Okay, so now go here and open the attribute table. Okay, here go and
Attribute tables, or even for the watershed boundary.
watershed boundary. No.
Not this one.
So select this, right click, and open attribute table, the third option. So here go and add field and name this one as area, and then say that one as a double, and then click OK. So now you created a new entity which is a part of your watershed. Okay, so select this by clicking on area. Okay, it will highlight this way, then it means you have selected it.
Yeah.
Right click.
It's not selecting.
No, go to the first one, area. No, yeah.
Got it.
Okay, go to calculate geometry. It will put a, you say yes to it.
Okay.
And then area, here you want it in acres, US acres.
Okay,
Acres, and then say OK. Yes. So it is a 391 acre watershed.
Okay.
Okay.
So I have a question.
Yeah.
So what if there are multiple polygons? What if you have created a different polygon on the same map?
So I mean inaccuracies in the points, right? So your area will be slightly differing.
No, I'm talking about the same map. I created a different polygon for a different stream
Yeah.
over here. Then how does it show?
No. So now I finished this, right?
Mhm.
So suppose you chose this watershed and created another polygon and made a polygon for that. Then when you want to go and find the area for that, you will have to select that one, say watershed boundary
yeah.
2,
Yeah,
and then do the area and do. Suppose if you are constructing sub watersheds here and you are editing and adding it in this watershed boundary itself, then in the attribute table it will show as the second row.
Got it.
So for that one, it will calculate what is the area for it. Okay.
If you want a combined area, then
Yeah. So combined area means this and that.
yes,
Then you will have to separately do it and then add them together.
add them together.
Yeah,
Okay.
yeah. The
Now,
tradition is
for
not.
example, we are doing for this river. This is one tributary that is contributing. There is another tributary that's contributing. Another one contributing. For each one, we do watershed separately. But if we want watershed for this river, then we have to add all of them.
All of them. So
That has to
exactly.
be done manually only.
Yeah. So there are a couple of ways of doing it. Suppose in this case, take this one as the example. You are having a subwatershed here. You have a subwatershed here. You have a subwatershed here, right?
Yeah.
If you constructed those subwatersheds in the same watershed boundary file,
Okay.
then they will all come as one below the other.
Okay.
Okay?
Yeah.
So you will have one for the entire watershed and for subwatershed 1, subwatershed 2, 3
Oh, I
and
see.
4.
There will be one entire one.
One
Oh,
entire
Oh,
one.
nice.
So,
Okay.
but when you are doing a 2 independent watersheds, you will do it as a separate watershed
Separate one. Got
file.
it.
I mean,
Got it.
okay. So this one you make them to do one more to finish. Okay. So any other question?
No, not for now.
Okay. So after doing this, make sure to save file.
Yeah.
Save as. Go to the same folder, whatever. What is it? Is in.
PNW.
Is it in the Google Drive, right?
PNW. Oh, OneDrive.
OneDrive. Where it is showing? N drive. It is N drive.
No, OneDrive. It says OneDrive.
OneDrive here. Okay.
The OneDrive. Is it OneDrive
it's right here.
PNW?
OneDrive PNW.
PNW. Yes. Hydrology.
Hydrology.
And,
Watershed delineation. Lab 1. Point of interest. So name this one as watershed delineation. Okay. And save. So when you save it as a project, when you come next time, you need not have to open one by one files. It will open them all as a project together for you. Okay. So this way you can have both watersheds what they created, and then in the lab report they should report what is the watershed area and what is the hydraulic length and okay. Is it okay?
Yes.
Anything else you have?
That's it.
Great. Subbarao. Great.
Thank you so much.